Hello and welcome to the equilibrium unit in SCH4U chemistry. Today specifically, we're going to be focusing equilibrium concentration calculations. So again, I recommend everyone grab their paper and pencils. Let's get right into it. Let's now take a look at the learning goals. So by the end of this video, I want my viewers to have an understanding of the following. The first is just the basics and the concept of equilibrium. The next is how to set up and properly use an ice table. And the next thing after that would be the equilibrium concentration calculations. So this is just how to isolate, solve, and plug in variables. Finally, we're going to look at the equilibrium constant K, which is simply the concentration of products and reactants in a given reaction. Let's get into it. So before we start any kind of calculations, I want to give you guys just a little bit of an intro to equilibrium so we actually know what we're working towards. So equilibrium is when a reaction has reached a state where the products and the reactants react equally, and the reaction therefore becomes reversible. Reactions occur at the same rate, and the concentrations of products and reactants remain constant. Okay, moving over. One more simple thing before we move over to equilibrium calculations is we're going to need to know the ICE table. So ICE stands for initial, change, and equilibrium. And it's a very simple concept. We're going to set up a 3x4 chart, and on one side of the column, the left side, we're just going to put initial, change, equilibrium, as you guys can see on screen. On the first column, you're going to put simply any values that were given. You're not going to put it in any units, just simply the value that was given to you for the initial concentration. Under the second column, change, you're going to write the number of moles next to either a positive or negative X. You're going to write it next to a negative X if it's on the reactant side, and number of moles of a compound next to the positive X if it was on the product side. Finally, you're going to write the equilibrium concentration given, if it's given to you, and if it's not given to you, you're going to write the initial concentration plus or minus the amount of moles X that you were given. Okay, so sample problem number 1. Calculate the concentrations of nitrogen monoxide and nitrous chlorine gas at equilibrium. Okay, so this isn't actually too hard. I'm going to take you guys step by step. Just follow along very closely. Okay, the first thing we're going to do is very simple. We're literally just going to draw out our ICE table. Once this is done, we're just going to write I for initial, C for change, and E for equilibrium in the 3 left columns. The next thing we're going to do is write the compounds of the reaction up top. So nitrogen monoxide, chlorine gas yields nitrous chlorine. Then of course write the moles as we write the whole reaction. So what were we given? We look at the initial concentration, 2 moles per liter. So we write 2 in the initial. It tells us chlorine is 1.5 moles. And it says no nitrous chlorine was present, so we just write 0. We now account for the change. Of course, we do negative on the reactants, positive on the products, and then account for molarity. So -2, -1, and 2. We were also given the concentration of chlorine gas at equilibrium. It's simply 0.90 moles per liter. To solve for the other equilibriums that we weren't given, we simply write the initial concentration plus or minus the change. The next thing we're going to do is we're going to solve for X. This is very simple because we know 1.5 minus X is equal to 0.90 moles per liter. This is of course respective to chlorine gas, the second column. Now we know X is equal to 0.60. We're now going to sub this in for our X values to solve for the equilibrium in our other compounds. So the equilibrium of nitrogen monoxide is simply 2.00 moles minus 2 times X, which is 0.6. This gives us a concentration of 0.80 moles per liter. Our next element we're going to do is the only other element we have to solve for, nitrous chlorine. So we just do 2 times the amount of moles, that's 2x, which just gives us 1.2 moles per liter. And that's it. The concentrations of nitrogen monoxide and nitrous chlorine gas are 0.80 moles per liter and 1.20 moles per liter respectively. Okay, let's talk about a value called K, or should I say a constant. K is simply an equilibrium constant. It's the value you get when you divide the concentration of products by the concentration of reactants. It's very simple. So if K is equal to 1, you're going to have an equal concentration across products or reactants. If K is greater to 1, meaning you divide the concentration of products by concentration of reactants, and you get a magnitude greater than 1, this means there's a higher concentration in products, and then therefore if K is lower than 1, you get a higher concentration of reactants. This value of K is not in units. It's simply any given magnitude, which can show the ratio of products to reactants in any given reaction. Okay, as we look to the right side of the slide, we can see that hydrogen gas plus iodide gas yields 2 moles of hydrogen iodide gas. And so we know, obviously, the compounds on the right side are simply the products, and then the compounds on the left side are simply the reactants. So in this reaction, hydrogen gas and iodine gas are the reactants, and 2 hydrogen iodide gas is the product. So therefore, we know that K is simply equal to concentration of products over reactants. So in this case, it's going to be the concentration of hydrogen iodide gas all over the concentration of hydrogen gas times, not plus, sorry, times iodide gas. Okay, moving on to sample problem number 2. We have a lot of information here, but let's read it top to bottom and go through every step. So it says carbonyl chloride gas decomposes to form carbon monoxide gas and chlorine gas, and it gives us a reaction. So let's use what we have to solve for K. Okay, we know whenever we're given an equation and we have the initial concentrations, but not all of the equilibrium concentrations, we gotta make an ice table. So let's do that real quick. Okay, the first thing we're gonna do is simply write the given reaction from left side to right side, products and reactants, nothing difficult. After this, we're gonna look at the molarity. So it says a 2-liter flasks. We know concentration is in moles per liter. So we're simply gonna convert everything into concentration by dividing by 2. So there's going to be 0.3 moles per liter of carbonyl chloride and 0.50 of carbonyl gas. And then obviously it gives us chlorine, which is simply 0. We then write our change, which is negative, positive, negative, and we take into account moles, which are all 1. Equilibrium is simply the initial concentration plus or minus the change. Now we're isolating for X to solve for equilibrium. Thankfully, it gives us the concentration of chlorine gas at equilibrium, which is simply 0.150. And we know that chlorine gas at equilibrium is equal to X. So literally, X is just equal to 0.15. Now we can sub in X to our other points to solve for the equilibrium of carbonyl chlorine gas as well as carbonyl gas. Let's do that real quick. So now we know all the concentrations of the compounds inside our reaction. We now solve for K by multiplying the products and dividing them by the reactants. So let's multiply the concentrations of carbonyl gas and chlorine gas, which is simply 0.2 moles per liter times 0.15 moles per liter divided by the concentration of carbonyl chlorine gas, which is 0.15. This gives us our final answer of 0.2 moles per liter. Just like that, we're done. We successfully solved for K algebraically by using our given equation as well as ice tables and isolating for X. And just like that, we did it. We successfully learned the equilibrium concept, ice tables, equilibrium concentration calculations, and solving for K, all algebraically. So, until the next time, I'll see you guys.